So I am this is going to be more informal. I will tell you about the platform and then also show you a demo of how it works afterwards. And so first, a bit of background. So at Teknikio, our mission is to turn dreamers into inventors, and we design different hardware and software tools to help you create with technology. And Techniverse came as a part of this system. And so we started out developing more analog electronics and hardware tools. And then we started to think about what is the next level of this, and became very interested in the Internet of Things and smart devices, which I'll tell you more about why in a moment. And so this is what inspired Techniverse, which is an ecosystem for teaching and learning Internet of Things designed to connect and inspire today's students and tomorrow's workforce. And this work is funded here in the US by the National Science Foundation. And so Teknikio began, as I mentioned, as an imperative to confront several different issues in STEM and STEAM education. One of the main ones being the gendering of STEAM educational resources, another one being accessibility and cost. And so you can see here, these are two different science kits from the 60s, 70s, and the contents are the same, but they're really branded that, the lab technician girl kit she can only be a technician, while as the experiment lab is kind of showing the boy as the scientist. And so we are kind of designing between these two spaces without, outwardly saying the gender roles of what a girl or a boy could be. And the reason that we are so interested in this Internet of Things, you might have heard this statistic that 65% of children entering primary school today will end up working in completely new jobs that don't exist yet. And these jobs are said to be part of the fourth industrial revolution, which we are at the dawn, at the beginning of right now. And there are a lot of different examples of this fourth industrial revolution. If you look at maybe an Amazon packaging warehouse, hospital smart system, but we felt that it wasn't really present in the classroom. And so we wanted to design a platform that really allowed any student, any teacher, anywhere to work together and have this interface that's very easy to use and get started. And so this started out really as a design for a classroom experience, but with the pandemic, we've added a lot of new features, which I think have actually brought out more of this Internet of Things, and just some different things that we are really focusing on in our design of the interface and tools is the concept of virtual classrooms, elements and features for collaboration and social and emotional learning. And so we have built in tools to share and work with what we call collaborators, and also to share your code and your projects. And then another component of this is kind of the blended teaching. So we've made it possible so that people can participate with or without the hardware. And I will demo more of this in a few minutes as well. And then also thinking about home learning. A lot of students and parents are, not necessarily going back to school or going back to after school programs. So really thinking about the balance between self-learning, self-paced learning, and just more formal instructions. And so again, these are some little snippets of how we're pulling these together, and I'll go through in more detail a bit later. So you can see we have this educator profile, and this is allowing the educator to track student progress and to share different resources with the whole class. We have a built-in chat feature for students and teachers to communicate with each other. And then we also have lately actually been expanding our platform. That's coming in a second, to incorporate other hardware devices beyond the Bluebird board that we've designed in-house here at Teknikio. And some more statistics and numbers. So there were 20 billion, more than 20.5 billion connected devices in 2020. It's anticipated that this will more than double just in 2 years. And then by 2030, it's expected that we're going to have 500 billion connected devices in the world. And so this technology, this infrastructure is really all around us. And so we really feel that it's time to expose the layers of Internet of Things, connected technology, and inspire today's students to be at the forefront of all of this, and really be the change makers and inventors of tomorrow. And so at the most basic level, I mentioned the fourth industrial revolution, but the Internet of Things explores interactions between digital and physical objects through the transfer of data across the network. So this is a more formal definition. And just some quick examples. So this is one that might be more around health data and wearables, for example, connecting a smart backpack to a smart shirt to smart shoes that are maybe helping navigate as you walk across the city. Maybe the hat is measuring the light and giving you some feedback about this. So really thinking about these smart and connected devices as being embedded and integrated into everyday objects and materials that we're already using, and thinking about connecting them, to this network that's all around us. So another example is this smart highway, smart road system. So you may have, for example, a smart vehicle, and there are lots of different sensors these days in vehicles. So maybe it's connected to some cellular or Wi-Fi network, learning about traffic conditions. Maybe there's Bluetooth to unlock your car, turn on the heating system, and maybe there's other information going to the cloud about your position and time, and this is all helping the management of the traffic and road systems. And so as we think again of how can the Internet of Things be an educational tool, these are some of our arguments or our thoughts towards this. So as I mentioned, it's an industry trend, and they'll need to understand how to develop these systems in the very near future. 2030 is not that far off. It's interdisciplinary and broadens participation in communication. And so as with a lot of Teknikio's designs, we really have a focus on crafts and different materials. And so this is, again, very important to the Techniverse system. And as the examples I gave show, we really think about wearables, smart fitness systems, for example, or clothing, smart cities, things that are really concepts that are more accessible. And IoT can extend students' knowledge areas as they create, use, and analyze to maintain systems or build solutions. And so a Techniverse is a system of hardware and software that allows you to do just that. And so I think now we will we'll get into the system in a second. And so the main technology that we are using for our IoT platform is Bluetooth. And we decided to use Bluetooth along with Wi-Fi, but mainly Bluetooth because it's extremely energy efficient and ubiquitous. And so, we have so many different Bluetooth wireless devices around us, from our headphones to our computer, to keyboards and watches. As you think about it, you're already interacting with so many Bluetooth devices on any given day. And so we designed our Bluebird microcontroller. So I have one here to show. And I'll just go over some of the features of the Bluebird, and then also talk about some of the other end devices that we have incorporated. And so Bluebird is designed to be easy to incorporate into other projects, as I mentioned. So it has this round shape, which is popular in different wearable hardware. It has integrated sensors, so you can start making and building outside of the box. However, you can connect other hardware to it. So we have these input-output pins, both on the edge and in the center. There's a central connector that you can connect different shields and sensors to your board. And then we have the software component along with this, which is the Techniverse website in this case, which offers an easy way to get up and running, and allows students to engage immediately. And so I'm actually going to dive into the platform in one moment, but just to go over the features of the board. So I mentioned the Bluebird Bluetooth microcontroller, the input-output pins, and then we have a light sensor, accelerometer, temperature, and then we have also built-in LED and speaker. And so I'm just going to stop sharing for one moment and share the other screen here, which will be the Techniverse platform. And so when you first arrive at the platform, you have here some different explanation of how to get started. You can make an account. So here I'm already logged in. And under your account, we have different types, inventor and educator. So you can save different project inventions. There's data stored in this website, so I'll show you that in a moment. And the inbox is where you can actually share these Techniverse files with other students or teachers, what we call collaborators. And so you set your collaborators here. So everyone who is part of the Techniverse system, we have their email or username. And so you can simply enter it here. And once you're a collaborator, it means you can share this data. And so I'm going to try to just connect a few different things right now. And so when you click on the Tools tab, you'll see we have a few different options here. This one is called Control Center. And so let me just turn on the Bluebird. Just plug this in here. Okay, so you click on this Bluetooth icon, and then you're able to confirm the device. So you'll see here we have the Bluebird, and then we also have integrated support for the microbit, which is really popular, and a lot of students and teachers already have it. And as you might have heard during the pandemic, there's a lot of problems with manufacturing, and so we wanted to allow people to really use the platform with something they might already have. And so we chose the microbit for now and the mobile phone, which is why I've been on my phone. It's not anything that's part of the presentation in the system. And so when you click connect, this might be hidden by the video stream, but there's a little pop-up window because Google Chrome has built-in Bluetooth. And so I'm going to give my device a name here. And now we're live and connected. So I am just going to move my Bluebird around. So it's just in the room plugged into the wall for power. And you can see that the data is coming in live. We also have temperature data, light sensor data. We have the speaker, if maybe you can hear it. And then we have some LED controls so you can change the color of the light on your board. So this is like a little Hello World snapshot. We also have this draw feature, which is using the accelerometer data, and you can create a live drawing using your Bluebird as a virtual pen. And this is something that you can download. And I mentioned before the files. So if I said, save this data, then I could select what I want to log, and I could give this a name, save data, and this is going to be where I showed you in the profile settings, which we can go back and confirm in a second. And so now I'm also just going to connect with my mobile phone. And I'm just going to press this again. And now we're going to, there we go, press this. 1 second, my Bluetooth on is on. Actually, I'm just going to restart the system here. And then let's try this again. Maybe we're having a problem with the cell phone today, unfortunately. Okay, we'll leave that till the end. Sorry, this is a very new feature, so maybe I shouldn't have tried to demo. But in any case, you can connect your phone, as I mentioned, as an end device as well. And so if you have more than one device connected, what you can do is enter this comparison mode, and you can see the data coming in side by side from both devices. And then the next tool that we have here is the code builder. And so code builder is, again, over Bluetooth. Everything is happening in pretty much real time. And so we have different code blocks, and we designed this system to be very drag and drop, easy to use. And so you can just simply drag out a block and say, I want the data from the y-axis of my accelerometer. And I want to compare that to the temperature reading coming in live from my Bluebird. And you can just connect the blocks together. I'm actually going to do a new example and also show the internet blocks. And this is another IoT feature that we've built in. And so we have real-time data coming in, mostly weather data, but we have a few others that's location-based from different APIs. So we have the precipitation, whether the sun is out, the UV index, ozone, temperature, location of the International Space Station, This one is really neat, the weather float. These are these smart weather stations. This company deploys all over the world, and we were working with a school system in one of our pilots in Alaska that had these smart weather stations to get really local information because there's such a diverse variance there with the weather from island to island. And I'm just going to try the phone one more time while we're here, because I do want to show you. And here we go. Okay, sorry about that. And so, for example, the sun is on its way. Let's see if it's actually risen here in New York. So, 6. So the sun, okay, it has risen. And so this is just sending a digital signal, a true-false signal that you can then connect to something on your Bluebird. So you can say, okay, turn my LED green if in fact this is true. And so let me just grab here, if you can see the LED light on the board is green, and it's all programming in real time. So if I delete this, the light will turn off. We have also different controls, like I mentioned, for the shields. We have an LED matrix shield, and we have different effects that you can add in to make something blink or fade. We have logic. So as I mentioned, you can compare two values and set a trigger based on the output. And another feature that we've incorporated here is both the chat and the project assistant. And so this was in thinking about how to help teachers in this virtual environment. So you could say, for example, I'm making a robot that changes the light color when the precipitation is a certain condition, and you'll get little clues here of which blocks to use. And then as you put them out and you have an understanding of the system, so this is an output block, this is an input block, hopefully you can connect them and create your program. We also have a full code block guide here that goes in detail about each one of these blocks and how they're working. So we're coming up on time. I also wanted to show you the make code integration. So in addition to this sort of automatic Bluetooth coding, we have the make code, which is, if you're familiar, more like Scratch or Google Blockly. And with this one, you actually have to put your board into a different mode. So it's no longer receiving data and broadcasting over Bluetooth. You can download it and load it onto your board. But what's nice here is that you can then toggle to JavaScript or Python. And so we kind of see this as a leveling up system in coding. We also have an Arduino library. So once students are at that level, they can advance to really just writing type code. And as far as the resources on the platform, we have our invention database. And so here we have step-by-step instructions. So it was just Halloween. So we have some projects that show you how to make, for example, a smart pumpkin. And then there's going to be some code. So if I click here, it's going to, why didn't that work? It should open the code in the code builder platform. And you can see different products you might need for your projects and the materials as well. And then we also have some courses. And so, as I mentioned, we really wanted to tie to real world applications. And so the subject matter include music and technology, wearable technology. We have some more traditional ones such as physics and computational thinking, some more foundational systems as well. And these are all set up to be about 5 different lessons about the topic. And if you go to the module package here, you'll see that each one has a slideshow that you can open and incorporate with your students. And they kind of build up. So we can just look at this one. Actually, I'm sorry, can you see the latest one that I am showing? Oh no, you're not seeing the latest one. But if you click into this, then you'll see, sorry, I'm just going to switch the screen that I'm sharing by stop sharing. And here we go. And you'll see there's a slideshow with different facts, and then it builds up to a project about Bluebird at the end. And so each lesson in a module will kind of help you first understand the topic and then invent and create something of your own with the Bluebird. So it's really about this invention process and guiding you through the whole system. And so I'll just show you some more features as we're coming up on time. If anyone has questions about anything, please feel free to also type in the chat. So as I mentioned, this is the educator profile view. You can set up a classroom, you can track your student progress, and the system is also built to be very collaborative. So educators and students can propose new inventions, projects, or modules, and they'll come to us for review, and then we will we'll edit and approve them and share them with the broader community. And so this is just to show how the remote collaboration and data sharing and live coding is working. And so if I'm connected and I'm going live, this is going to go through the cloud, and then I would be able to watch and record incoming data from another device anywhere in the world, as long as you're logged into the Techniverse system. And you can also read the information from your collaborator's device. So currently we have read permissions, so I can see sensor data coming in. We're also going to be adding write permissions and expanding our features around learning about privacy and data sharing. And so this is just a little bit more of how all of the different features work. We also have YouTube videos to go into this. And as I mentioned, we have these 3 different types of output blocks that you can connect together in your program. And yeah, this is kind of it. We're coming up on time. So so this is just to show how it looks when you go live and you see two data sets coming in side by side. The project assistant, which I showed you, and the chat feature. Unfortunately, it's a little bit early here, so I don't have anyone online with me.
Thank you very much, Darren.
Yeah,